once you've set up a problem and learned to do dimensional analysis properly, then you need to learn how to properly round those final answers. You also need to know how to round when you're doing addition and subtraction. That's what this lesson is about. So here's the homework problem I assigned yesterday, and the solution works like this. The first thing you are required to have for a conversion problem like this is to write out the equality statement. Now yesterday in the example, I showed you an equality statement. Let's see. Here was the equality statement I showed you yesterday. But I also said if you don't have it written out for you, you have to write out the equality statement. So let's look here. If there are 0.716 grams of methane in 1.00 milliliters of methane, that right there tells you those two things are equal, right? Okay. So we got 0.716 grams, and there's the symbol for methane, CH4, kind of saves us some space, and that's equal to 1.00 milliliters. And when we symbolize liters, whether that's milliliters in front or liters by itself, please use a capital L. It's a whole lot easier than telling what you mean when you write a small letter L. If you write a small letter L, I don't know if that's a number 1 or the capital I letter or what it is, okay? So capital L, whenever you're doing liters, always use a capital L. So that's milliliters of methane. Okay, and then the question is how many milliliters are in 2.55 grams of methane? So the starting amount here is the 2.55 grams of methane. We're trying to find out how much of this methane there is. We're not going to change the measurement. We're not going to change the amount. We're only changing how we're measuring it. That's what this does. Okay? So we're going to take that 2.55 grams of methane, and we're going to put that over 1. Okay? Now we're going to go over here to the equality statement, and I want to find which side of the equality statement matches the units and species I have in the top of this fraction for the starting amount. Okay? Well, the left side here of the equality statement matches this one. So that's the side of the equality statement that needs to go on the bottom of the fraction where we're going to create this conversion unit. So 0.716 grams of methane goes in the bottom. And then the other side of the equality statement goes on the top. Okay? Now it's very important that you always show your math operators. In this class, if I don't see math operators, I count off points. So times signs, now some people like to use the dot, and that's okay. You can use that dot that means times. It actually means two different things, but at this level, the math you're doing, it doesn't really make any difference. You won't find out why they're different or how they're different until you get to like the 4th calculus class you take in college or something, okay? So it's higher math where it starts to mean something different. All right, so now we're ready to do the math. Now before we do the math, I want to simplify. As I showed you yesterday, if I've got the same units on the top and bottom, they can be canceled. And I want to see that. That's required. Again, if you don't have that, I'm going to count off points, okay? So, and the same with these species. If it's the same on the top and bottom, I'm going to cancel that. So now we're ready to start doing the math. I can get my mouse to work. Here we go. Let's see, this is what I did. Actually, no, that's not the same math we did. I did that. That was from yesterday, actually. Okay, so 2.55. Now, if I multiply across this, let me bring this back up here for you. If I multiply this times 1, I'm just going to get the same number, right? I don't really need to do that math. All I really need to do is take this and divide by that. I'm going to go ahead and show you that math just to show you it comes out to be the same. But then we're going to do the division part. So the way this works is you're going to multiply this times this and hit equals, then hit the divide button and put that number in and hit equals again. And that'll give us the answer. That's the fast way to do this kind of math, since all this math kind of works the same way in this class, pretty much, okay? So 2.55 times 1.00. As you can see, you get exactly the same thing. Now we're just going to hit the divide key, okay? And we're going to put in this 0.716 and hit enter. Oh, did I do the wrong one? Okay, I didn't do the whole thing right. Okay, so 2.55 divided by 0.716. I didn't press the button well. There we go. All right? And then we want to write down that complete answer. All those numbers need to be in the answer. 3.56145. And then since the units we have left are milliliters, we're going to keep that. The species we have left is CH4. We're going to keep that. Okay? And that is as much as I asked you to do last night. Okay? Any questions about that? So let's talk about how this is going to be graded. Okay? All these things I'm asking you to do are important. They're required. I expect to see them. So I'm going to give a point for showing me this number, unit, and species. That's 3 points. I want to give you a point for showing me the equal sign, because that's important. This number, this unit, and this species, okay? So just the equality statement is worth 7 points if it's written properly, okay? Okay, 2.55 and grams and CH4. All those are worth points, as are canceling out grams and CH4. And putting all of this over 1, that's a point. This operator here is a point. 1.00 milliliters of CH4, all 3 of those are points. All this down here, 1, 2, 3, plus the cancellations are points. The equal sign's a point. The answer's a point. Units of measurement and the species are points. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 points for this part. Okay? So altogether that comes out to be 26 points for this problem. Okay? So look at the paper you're grading. Give them the points they're supposed to have. Make sure you're correcting what they don't have and explaining to them what they need to have that they don't have. Okay? And then we'll tell you how to put the points on the paper in just a minute. Give you a chance to work on that. If they do everything else right, but they put the work in the calculator wrong and this answer right here is wrong, all the other pieces are there, they only lose 1 point. Okay? It's important that you understand that. Setting it up right is what's the most important thing about your homework. Okay? It's not so much that you get the right answer in the calculator. We'll get to that. If you can set everything up, you're going to get the right answer eventually, because we're going to practice it a lot. Okay? So if they get the wrong answer, that's just 1 point off. So this is worth 26 points. What I want you to do is to put that, whatever points they actually earned, at the top of their paper. So remember, they got their name up here, the date, description, my name, somewhere up here in the center of the top, in a box like this, or in a rectangle like this, put in the number of points they earned. You don't have to say points. You can just say 26 or 25 or whatever they earned and put a box around it. Okay? That's how you're going to help grade the paper. The best thing you can do is to turn in your makeup work when you're making up from something like this. If you've done your homework, the best thing to do is turn in the makeup the next day. I actually don't count any points off if you did your homework on time the first time, did a reasonable job in trying, and you're doing the makeup. As long as you turn it in before the unit test, I don't typically count off any points for that. Okay? But if you want to do the best you can in this class, I would go ahead and do it the same night, that very night, if you can. I mean, if you get so wrapped up in that's something you got to put aside, you can do that. But if it isn't turned in before the unit test, you don't get credit for doing the makeup on it. Okay? Now, if you don't do your homework and you turn in the makeup work the next day, you lose 10%. If you turn it in 2 days later, it's 20%, and so forth. Okay? Everybody got that? So do your work on time, do the best you can, and if you blow it, you still got a chance to make it up. Fair enough? I mean, later in the semester when things start to get, you got a long problem and stuff, and if you mess up the makeup, I'll let you do the makeup, a makeup. Okay? I want you to get it right. Okay? Fair enough? And it's kind of a modified way of what they call mastery learning. Okay? I want you to keep working at it until you can get it.
So
within limits. I mean, we have to get through the unit and have a end of unit test. But I want you to do, get every opportunity you can to do the best you can. Okay? Good? All right. Everybody got this? Okay, then. We're going to take what we learned last night and today. Yes?
Did you change that? Like, that 7 point, what is that supposed to be?
8, 6. Yeah, well, I kind of messed up there and I wrote over it. I'm sorry you having trouble with it there. Why would you do it all over again?
I thought it was 0.
Well, just write 7.86 over it and cross it out.
I got all 26 points of that. Oh, yeah. So, does it matter if we put 7.86 over the first side?
Well, I really want you to put your starting amount first. Is that what you're asking? Okay, listen up. This is a really good question, all right? Listen. What she's asking is if on this work, if you got the starting amount and the conversion unit switched around. Yeah, I want the starting amount first. Because when we're doing stoichiometry, it almost has to be first. Okay? You almost can't solve it without putting it first. I want you to get used to that pattern. All right? So always put the starting amounts first. Okay? I probably wouldn't count off if you did it the wrong way, but I want you to get it done in the right way now so we can get in that pattern. Okay? All right, everybody good with that? All right, going. All right, let's talk about rounding now. So yesterday we did that work, or last night you did that work, and now what we want to do is take that answer and come up with the way that you're supposed to round. So yesterday's practice problem, we did this one right here. Okay, so I'm going to start with this to start talking about how to round properly with the multiplication and division. All right. So this is where we left that problem, the practice problem yesterday. We did cancel out the units, that's required. Now this is both a multiplication and division problem all in one. Okay, it's both a multiplication and division problem all in one. It's multiplication across the top and division from top to bottom. Okay, so fractions are basically a division problem. First thing you want to do is to identify, and ID just stands for identify, or identification or something. So you want to identify the measured and calculated numbers. And the problem. Well, I guess first of all, you need to make sure you've got a multiplication division problem, because this rounding process doesn't work. The one I'm going to show you now anyway doesn't really work unless you're doing multiplication division. So the first thing you really need to do is identify a multiplication division problem. And then you're going to identify the measured and calculated numbers. And they are what they sound like. Measured numbers are those that are simply measured. Calculated numbers are those that take measured numbers and multiply, divide, add, subtract, whatever to get an answer. All right. It's not so much critical that you know the measured from the calculated. It's critical that you know how to recognize a measured and or calculated number. Now, it's not the final absolute way of doing it, But a really good guess that you've got a measured or calculated number is when you have a decimal number, like these two right here. Okay, they're decimal numbers. They are more than likely a measured or calculated number. Okay, this one is actually measured. Somebody, you can put something on a balance and measure grams, right? But now when I have an equality like this came from an equality statement in yesterday's work. Where did I have that? Here it is. All right, here's the equality statement we wrote yesterday. Somebody had to actually calculate this amount, all right, to get there. Technically, this was actually looked up somewhere, but originally it had to be calculated somehow or other. Okay, but any of the equality statements or conversion unit setups like this, those are always calculated numbers. Now, this number here is not calculated, all right? This number is put there to remind you, excuse me, what this number relates to, okay? You could write this very simply as, could be written as 12.01 grams per mole of carbon. We could write it that way. It means the same thing. But when I write it that way, it means that 12.01 grams of carbon equals 1 mole of carbon, and we do it this way because it makes our math work out really, really nicely when we're doing the longer problems we're going to do later in the semester in the category we call stoichiometry. So first we're going to determine what the measured and calculated numbers are, and that's this number and this number, okay? So 45.0 grams of carbon is measured, and 12.01 grams of carbon is calculated. So those are our measured and calculated numbers. And once we determine what the measured and calculated numbers are, then we're going to determine which of these measured and calculated numbers, and in some problems later in the semester, there are going to be like, 5 or 6 of these different numbers in one problem. We're going to determine which of these have the least total digits. So 45.0 has 3 digits. I know you guys are used to in math classes and maybe even earlier science classes and thinking about that 0 as not even being a digit. You kind of put them in there when you want to and take them away when you don't want them to have them and things like that. But zeros are very important. They tell us how precise the measurement is, and we'll get to that later in this unit, okay? So that 0 has to be there. That 0 tells me how precise that measurement was when it was originally conducted or done, okay? And so 12.01 has 4 digits. So digits are the actual number symbols here, okay? That corresponds to the digits on your hand, okay? How many fingers do you have? Okay, you have 10 digits, right?
Oh.
All right, you didn't know that? How many digits do you have on your toes? 10 digits on your toes, okay? So it's all part of that base 10 numbering system we use in the human race, okay? All right, so this number here, this 45.0, as you probably can tell, has the least digits. All right, so your answer to the problem must be rounded to have the same number of digits as the measured or calculated number with the least digits. Okay? Now, once you figure out how many digits you want in your final answer, you're going to underline the digits that will be rounded off. And these digits that we're going to round off are called insignificant digits. And then after we do that, we round off, or rather we underline the insignificant digits. Then we're going to draw an arrow to the rounded answer. So let me show you what that's going to look like now. And you don't have to write it out a second time if you don't want to. You can, if you've written it out up here, you can go back up there and continue that work to do the same thing I'm doing. But I want to write it out here for the purpose of the notes here. Okay, this is where we stopped the last time. All right, so we've determined that we need to have 3 significant digits in our final answer. Okay, because 45.0 has the least digits of the two numbers we're interested in, the two that fall in the category of measured or calculated. 45.0 has the least digits. And so we're going to look over here and we say 1, 2, 3. Those are our significant digits. The first 3 digits are our significant digits because they match the number of digits the measured or calculated number in the problem has, or the measured or calculated number with the least digits has. And so we go over here and we start to underline all the other digits. Those are the insignificant digits. Okay? And then we draw an arrow to show that we're rounding off, and draw the arrow to the rounded off answer. And then we're going to round this off to what? 3.75, okay? I know that the way that you've been taught in school up to now is that if you're rounding off all these other digits over here, then you look at the first digit that you're going to round off, and if it's a 5 or higher, this makes this digit round up. And if it's less than 5, then this digit stays the same. That's the way you've been taught in high school. Now, there is a better way to round off. We're not going to learn that in high school chemistry, but in some college classes and maybe some higher level high school classes, you might learn this new way of rounding off that's actually more effective. The way that we're doing it actually does something called propagating an error over the long term if you do lots and lots of calculations with the same work, the same measurements and calculated numbers and things. But we're not going to worry about that right now, okay? For now, we're just going to stick with the same rounding system you've been using since, I don't know, first grade or something. So it's 3.75 moles of carbon. Then I'd like for you to put a rectangular box around that answer so I know in those really long problems we're going to do where your final answer is located. Okay? All right, you get all that? You can write this on the same paper because this is just practice. But this is a practice problem for you to do. Now, in my classes, I want you to work with other people. Okay? When you're doing class work, I want you to collaborate. All right? It's better for you to collaborate than do it by yourself, in my opinion. All right? Because then you kind of feed off each other. You have questions for each other, And it helps a lot if there's a lot of confusion, because you'll clear it up before you call on me. Because there's only one of me, and if I have to go around about 3 or 4 people, then you got to wait on me, okay? So I'd rather you collaborate, all right? So work with each other, figure out how to solve this problem, work it all through if you can, and if the 2 of you get stuck, and find whoever you want to that's near you. I don't want you to get and walk around, but just find somebody near you. Hopefully there's somebody near you don't mind working with. So this is the proper way to solve the problem, with all the pieces and parts have to be there, okay? Equality statement with all the units and species are required. Canceling out numbers, all the units and species are required. Must put your starting amount first. Then build your conversion unit. Give the full answer. Underline insignificant digits. Arrows, equal signs, time signs are all required. Rounded answer with units and species is all required. Okay? No, your homework has to be on a separate sheet of paper. No, this has to be on a separate sheet of paper. All right. So there's a different set of rules for addition and subtraction. And the way that you're going to set up the problems is you're going to set them up vertically, stacked, where your decimal places lined up properly. So here's an example where I've stacked the numbers that I'm going to add together. Okay? 12.1 milliliters of ethanol, 3.47 milliliters of ethanol, and 1.436 milliliters of ethanol. Okay, I've stacked them. And notice I've got everything lined up nice and neat, so the decimal places line up and the digits line up. Okay? Now what you're not going to do is put extra zeros on these numbers. I know that's the way you've been doing it since, I don't know, 1st grade, 3rd grade. I don't know when you started doing that. In order to stack them neatly, you put extra zeros on there. The problem with that is that in the sciences, when you put extra zeros on there, you are, by doing so, lying about the precision of that measurement. Okay? And I don't want you lying, right? Because the numbers that are written tell us how precise the measurement is. The way they're written tell us how precise the measurement was to start with. And so if you put extra zeros on there, you are indicating there's a level of precision that doesn't exist. So we do not put extra zeros on the numbers. So you can't write the 12.1 that I have up here, for example, as 12.100. You cannot do that. Not allowed. You are allowed to use arrows as placekeepers instead of zeros, because arrows won't be read as numbers or digits. Okay? Okay, so let's see what that would look like if we put some arrows in there just to kind of keep everything aligned properly, okay, or nice and neat anyway. Okay? So here I put arrows in there instead of zeros. Putting zeros in there would be lying about precision, but arrows aren't read as numbers, so we're not lying about the precision. You don't have to have arrows. You can leave the arrows off. I like to put them in there just to show you where the digits are missing. That makes sense? Because that's going to be important in rounding off here. So I added the numbers up. I kept all my digits nicely aligned. Okay? 12.1 milliliters of ethanol, 3.47 milliliters of ethanol, 1.436 milliliters of ethanol. Add those together, you get 17.006 milliliters of ethanol.
When we say it like 17.006.
If you're going to say it out loud, that's probably the easiest way to say it, because the other way to say it would be 17 and 6 thousandths, which you could do. That's okay. All right, if you know how to do that. I think most people just say 17.006 when they say it. All right. Now, then we're going to round off, that should be off and not of, round off the digits resulting from those empty slots. So where I put arrows there, those are empty slots. And so above this last 6 in the answer here, I have 2 empty slots in that column. Above this 0 here, I have 1 empty slot. So those 2 digits right there have to be rounded off because there are empty slots there. Okay? Now, that's sort of like the rudimentary way of thinking about it. The reason why we do that is this. If I had measured either one of these first 2 numbers with a more precise device so that I had those digits where they're missing digits right now, these 2 numbers would have been different. We don't know what those numbers really should be. Does that make sense? That's why we're rounding off those 2 digits, because they are truly insignificant. We don't know what they really should be. This 6, if those are 2 zeros right there, that should be a 6. But if we measured that with a more precise instrument, and this was a 1 and this was a 3, then this would be a 0. We don't know what that digit would be. So we're going to round those off because they're insignificant, okay? So the way I do that is just like this, like we did before, okay? We've got the empty slots there. We underline the insignificant digits where the empty slots exist. Use an arrow to show a rounding off. And the answer becomes 17.0 milliliters of ethanol. And that 0 stays because it is significant. Okay? We keep that 0. That's a significant 0. All right. Now, you've got a homework problem that goes along with the addition and subtraction then. Give you a chance to practice.
Can it be on the back or?
Well, I'd rather have them on the same side of the piece of paper. So this homework I gave you earlier today can be on the same sheet of paper as this homework. We could call this homework number 1, and this is homework number 2, if you want to do it that way, okay? All right. Okay, I want to go over a couple things before we finish up today. So get out your lab logbook because I want you to put a couple things on the inside cover again before we're done for the day. These videos, and by the way, I'm recording. I don't know if you noticed, but I'm recording. I may have said it earlier. I'm recording this, what we're doing today. Okay.
Recording your voice?
I'm recording my voice. I'm recording what you see on the screen. Everything that's underneath this camera right here is being recorded. Okay. So that becomes part of a recorded lesson for today.
Can you hear
So-
it in the background?
Well, I don't hear the students as well, but if any of you spoke up loudly, I probably could. But that's beside the point. Let's move on. Okay. So here's the thing. These are all posted on my YouTube channel. Okay. So you go on my YouTube channel. If you get behind, or maybe you're not quite sure how to do something, you can go on the YouTube channel. You may, if I record a lesson that day, you may see that lesson to help you. So you're doing your homework tonight and you're kind of struggling, you can go look it up. How do you do that? You know, see what it is. All right, now, in addition to today's video, there may also be a lot of other videos that cover the same kind of stuff. So you can see it covered 2 or 3 or 4 times if you want to. I have like 800 something videos at the point of time where I'm recording this video already on YouTube. Okay, so there's a lot of stuff there for you. And they're all laid out in playlists. So if you go look for how to find, you know, this stuff, you may find other videos that also cover this stuff. Okay?
Did you start with the night?
When did I start doing? Oh, I don't know. It's been years ago now. Okay. So first thing I want to do is show you how to get to the class YouTube channel. Okay. If you were to go onto Google and just simply put in Tedder Chemistry YouTube. Okay. Tedder Chemistry YouTube. It's kind of like one word, Tedder Chemistry, like my website. Okay. Huh? When we get to the YouTube channel, you will. Okay. So I'm going to click on this. That's the link to the YouTube channel right there. And this is what you want to put right up here at the top. This is the web address you want to put on the inside cover of your lab logbook. All right, I'm Mr. Tedder. I want to tell you about a new class we're offering here at Gilman High School. So here's the curriculum guide. Okay? And that'll play automatically. Just pause it. I may put a different introductory video on there later.
1 year ago.
I made a YouTube video.
All right, so this is the web address you want, guys. Make sure that web address is in your lab logbook on the inside cover so that whenever you're looking for things, you know where to find it. Now, that's the place I'm having you put all these things you need. Your academic email address and password, your computer password, your computer username, your It's Learning username and password. All that's supposed to be on the inside cover of your lab logbook. Okay? All right, www.youtube.com/user/Tedder Chemistry. Okay? If you forget that, you could look it up, and that's what I was showing you a while ago what to do. Now, in addition to that, there is a class website. Okay, let me show you the class website. Huh? You want to write the class website address on the inside cover of your lab logbook. Okay? I'm going back one page here if it'll ever get there. There we go. That's the actual web address that you want. Okay? www.tedderchemistry.com. So that's pretty easy. The YouTube channel and the website address are kind of the same, aren't they? All right?
Do we get to do that this year?
No. Okay. Make sure you write down that web address. I got to show you how to get to your class page on this web address, okay? Just put the web, everybody got the web address written down? All right. So if you look over here, it says all chemistry classes. There's a drop-down menu. You're going to click on Chemistry 1 Advanced, and there's your class page, okay? And you scroll down there, and you can find just about anything you want to know about this class. There's a calendar. Okay, every time I add something to the calendar, it'll pop up there. Okay, if you scroll down here to where it says Unit 1, that's where we are now. Everything we're covering in this class is found, almost everything anyway, is found in this section. Now, you know already we don't use textbooks in here. Sorta. The textbook is right here. This Unit 1 right here, that's the textbook for this unit. And in every unit section, you'll have a new textbook listed there. All you do is click on it, and there it is. If you're out for an extended period of time, this is everything you need to know for the test, just about. I mean, there are a few things we do in class with labs and things, but those can be picked up with YouTube videos as well. Almost all of them, okay? So you could almost stay at home and pass the test in the class if you actually worked at it, okay? You with me? I didn't say pack up yet, guys. Hold on. Not quite done. All right? Now, does anybody have any questions about how to access these things or what to use them for? Okay. So you've got 2 homework problems. You have a safety test tomorrow. So you're both supposed to be studying, should have already been studying the safety contract. Okay? I've sent you 3 videos on safety already that would help you if you'll use those.